Welcome to the deep dive. For years, the whole conversation around artificial intelligence was, well, it's basically science fiction, right?
Absolutely. Robots, supercomputers, the future.
Yeah, exactly. But if you're working in really any industry today, that's not the reality anymore. AI isn't some far off concept. It is, right now, probably the most powerful force actively reshaping, well, everything.
Yeah.
Business operations, supply chains, medical discovery.
Driving efficiency across the entire global economy.
Yeah.
It's already here.
It is. So our mission in this deep dive is, I think, pretty crucial. We're going to try and cut through all the hype, all the speculation,
All the noise.
all the noise, yes, and really just extract the practical, the measurable ways AI is solving real-world challenges today. We want to equip you, the listener, the learner, with, tangible impact, not just potential.
But what's actually working?
Exactly. We've stacked our sources, and they're heavily focused on case studies, on real metrics of transformation in some really high-stakes industries, and on the philosophies of the people building these intentional AI systems.
The ones designed to solve very specific problems.
Right. We're looking for those aha moments that explain how AI is driving accuracy and better decision-making on a scale that, frankly, humans just can't match. So let's unpack this. We talk about AI all the time, but I think we often forget to define the fundamental shift. What is it, really, about modern AI that makes it so much more powerful than the traditional software we've all been using for the last 50 years?
That distinction is, it's everything. It's the key to this whole moment. Traditional software is what we call deterministic.
Meaning it just follows rules.
Exactly. It's a set of fixed sequential rules coded by a developer. If the input is A, the output is always B. Its strength is its predictability.
Which is great for some things.
Oh, fantastic. For things like calculating taxes or running a payroll system, you want that to be deterministic.
Right.
But modern AI is fundamentally different. It's
Yeah.
adaptive. We're talking about systems that do things that used to be exclusively human.
Recognizing patterns, making predictions.
Complex stuff. Pattern recognition. Making predictions with messy, noisy data, inference, dynamic decision-making. The real shift, the paradigm shift, is that AI learns from data. It continuously improves its own performance. It adapts to things it was never explicitly programmed for.
So it's not just a faster calculator.
Sure.
It's a system that can actually interpret a complex reality. The ability to learn rather than just follow a list of instructions that changes the entire game.
It's a completely different category of technology.
And yet, the theory behind this has been around for decades, right?
Yeah.
So why this explosion just in the last 10 years or so? What were the acceleration factors?
It was a perfect storm, really. A confluence of three huge factors that all matured at the same time.
Okay.
First, you had the breakthrough development of powerful neural networks, specifically the rise of what we call deep learning architectures.
Deep learning. We hear that term all the time. Can you break that down for us? What does that functionally mean?
Yeah, of course. So think of traditional machine learning as maybe having one or two processing steps. Deep learning introduces dozens, sometimes hundreds, of interconnected layers.
Layers of what?
Layers of computation. So in the early shallow layers, the AI might just identify very simple things in an image, like an edge, a straight line, a specific color.
The basic building blocks.
Precisely. Then, in the middle layers, it starts to combine those blocks into more complex shapes. A wheel, an eye, the corner of a building.
It's starting to see objects.
Exactly. And then in the final, the deepest layers, it recognizes the abstract concept. It puts it all together and says, that is a dog, or that is a faulty circuit board. This multi-layered, hierarchical way of extracting features is what lets it solve these massively complex, nonlinear problems.
That makes so much more sense. It's actually building an understanding layer by layer, not just matching keywords. Okay, so that's factor one. What were the other two?
The second factor is just data. So much data.
The fuel for the engine.
The fuel for the engine, exactly. These deep learning systems need enormous amounts of high-quality data to train on. The digitization of everything, e-commerce, streaming, all the sensor data, massive research databases, it finally provided that fuel source. 20 years ago, we just didn't have enough structured data to make these models work properly.
And the third factor?
The third one connects everything together, the cloud. Robust, affordable, scalable cloud computing.
The infrastructure?
The global infrastructure. Running these huge neural networks on petabytes of data requires immense processing power. Without the cloud offering that compute power on demand, AI would still be stuck in a few research labs. The cloud basically democratized access to the horsepower needed to train and deploy these systems globally.
So you get the sophisticated brain of the neural network, the fuel of massive data sets, and the engine of the cloud. And when those three things combine, you said they grant AI four key superpowers.
That's right. Four things that really let it surpass human capacity in these complex challenges. The first one is just sheer velocity.
Yeah.
Unbelievable speed.
Right.
An AI can analyze millions of data points in seconds. A human team could spend months just trying to collate that data, let alone analyze it. The AI digests it all and finds correlations in the time it takes to, make a cup of coffee.
Velocity is impressive, but the second one you mentioned, that one feels like the real cognitive leap. The ability to learn patterns that are actually invisible to humans.
This is where it stops being just a faster human and becomes a new kind of intelligence tool.
How so?
Sometimes the connections in the data are just so subtle or they're spread across hundreds of different variables. A patient's genetics, their diet, their zip code, past prescriptions.
Things a human brain just can't juggle all at once.
Exactly. Human intuition just can't connect those dots. But the AI can find these tiny micro patterns, these subtle signals that predict an outcome that human experts completely missed because they were looking for more obvious linear connections. It's literally seeing a reality in the data that was statistically invisible to us before.
Wow. Okay.
And that leads right into the third superpower, which is scalable automation.
Taking that insight and putting it to work.
Right. It automates workflows that used to take hours or days or even weeks of manual, repetitive human work. This frees up people for higher value things, creative work, strategy, interpersonal tasks. It fundamentally changes the economic structure of how we work.
So it's not just doing the same task faster, it's about restructuring the human role, moving us from process execution to strategic management.
100%. And the final superpower is consistency.
No bad days.
No bad days.
Yeah.
Exactly. AI makes consistent decisions without fatigue, without boredom, without emotional bias. And that consistency is absolutely critical in high-stakes environments.
Like a hospital.
A diagnostic system in a hospital, a flight control system, a financial compliance engine. Human performance naturally fluctuates based on stress, time of day, how much work is on their plate. AI performance is just maintained. Precisely at the peak level it was trained to achieve.
So if you put it all together, unmatched speed, seeing invisible patterns, massive automation, and total consistency, the business implication is crystal clear. You can drastically increase speed, reduce costs, and, I imagine, elevate the customer experience through personalization.
It completely shifts the competitive landscape. The question isn't, will AI be a differentiator someday anymore? It's, how quickly can we deploy intentional AI systems to start getting a return and redefining our market? And that, I think, brings us perfectly to our next section. Because the true test of all this isn't the theory, right?
It's the results.
It's the quantifiable, measurable results happening right now in these high-stakes fields. So let's look at the case studies.
Yeah.
Where is this actually making a profound change today?
Let's start with healthcare. I mean, it's the most sensitive, life-altering sector there is. Our sources really highlight how AI is making diagnostics faster and, more importantly, much more accurate.
This is really the perfect application for AI's pattern recognition ability. I mean, what is medical diagnosis, really? It's a pattern matching exercise.
You're matching symptoms, test results, scans to known diseases.
Exactly. And by training an AI on global data sets, we're moving beyond relying on just one single doctor's personal experience. We're augmenting their expertise with algorithmic consistency on a massive scale.
Okay, let's get specific. The example in our sources about mammography and cancer detection, what was the setup there and what were the actual outcomes?
So this was a major hospital system in California. They deployed an AI imaging algorithm specifically for reading mammograms. And the system was trained on just an immense data set, over 500,000 previously analyzed images.
Wow.
And the AI wasn't just taught to look for the obvious masses. It was trained to identify these incredibly subtle markers, things like microcalcifications or tiny changes in tissue density that a human eye might struggle to spot consistently over a long day.
And the big number from that study, a 20% increase in accuracy. What does that actually mean?
It means it detected early-stage breast cancer 20% more accurately than the traditional screening methods, which were reviewed by human experts alone. And you have to understand the gravity of that number.
It's not just a statistic.
No, a 20% increase in accuracy for early detection translates directly into lives saved. It means significantly better treatment outcomes because you're catching the disease at its most treatable stage.
Beyond that incredible accuracy gain, What did it mean for the hospital's operations, for the patients and the radiologists?
Well, for the system, it meant a huge reduction in false positives.
Which is a huge deal for patients.
A massive deal. A false positive causes so much unnecessary anxiety, emotional distress, and it often leads to costly, invasive follow-up procedures like biopsies for people who are perfectly healthy.
So it saves money and preserves patient well-being.
Right. And for the radiologists, it was a productivity tool. It accelerated their review time by instantly flagging the high-risk cases. This let the human experts spend their valuable time focused on the really complex, borderline cases that required critical human judgment.
So it's acting like a tireless, hyper-vigilant second opinion on every single scan that comes in.
That's a perfect way to put it. And this is expanding way beyond mammography. The sources highlighted that AI is now a critical tool for assessing stroke risk.
How does it do that?
It analyzes a patient's demographics, their full medical history, and their imaging scans all at the same time. It's also detecting diabetic retinopathy, a leading cause of blindness, by studying retinal scans for minute damage to blood vessels. And it's even flagging heart disease patterns that are invisible to clinicians because they involve those complex multi-factor correlations we talked about earlier.
That's the key, isn't it? The shift from a single data point to a multi-factor correlation. Okay, let's move to our next high-stakes field, climate modeling and environmental monitoring. The complexity of the data here must be just astronomical.
It is. I mean, climate change and local pollution demand incredibly accurate, high-velocity forecasting. You're processing petabytes of dynamic data from the atmosphere, the oceans, the land. It's a perfect task for machine learning.
The source material had a really compelling example about urban pollution control. Tell us about IBM's Green Horizons project.
Right, so Green Horizons use machine learning models to analyze thousands of data points in major cities, mostly in China. Things like traffic flow, industrial emissions, weather patterns, local geography.
All to model pollution patterns.
Exactly. But the real value was in its predictive power.
How far out could it predict?
It could predict pollution levels a full 72 hours in advance.
3 days.
3 days. And that lead time is transformative. It allows a city government to be proactive, not reactive.
Yeah.
They could issue public health alerts for vulnerable populations or even temporarily adjust industrial regulations.
Like shutting down a specific factory for a couple of days to prevent a severe smog event?
Precisely. It shifts the entire posture from prediction into active prevention.
72 hours is enough time to actually change policy and behavior. What other critical environmental uses did the sources highlight?
A big one is wildfire detection using satellite imagery. The AI can differentiate a smoke plume from a cloud, which is harder than it sounds, and then track the fire spread based on wind and fuel models. It's a much broader, faster surveillance capability than human patrols.
I can see that.
It's also huge for agriculture. Predicting local weather patterns helps farmers optimize their planting and harvesting schedules to maximize their yield. And then there's real-time flood risk analysis.
How does that work?
It combines rainfall data, soil saturation levels, and topological maps to forecast which specific neighborhoods might be just minutes away from being inundated. It's far more precise than a generalized regional alert.
And when prevention fails and disaster does strike, the focus shifts immediately to rapid response. In an emergency, every second counts.
They absolutely do. The case study on the Nepal earthquake is a perfect illustration of this.
Right. The problem there is that traditional damage assessment is slow and dangerous.
Incredibly, you have human teams trying to navigate rubble. But in Nepal, they deployed AI-powered drones. They captured high-resolution images of the collapsed zones, and an AI algorithm immediately analyzed them, checking building integrity, identifying where major collapses happened, and even looking for signs of life.
And the speed advantage was?
It was staggering. They mapped the destruction 10 times faster than manual ground teams ever could have.
10 times faster. In that first 72-hour window, that is literally the difference between life and death. How did that speed help the rescue crews on the ground?
The rapid mapping guided rescue teams directly to the highest risk areas, the places with the highest likelihood of finding trapped survivors. So the impact wasn't just efficiency, it was reducing that critical response time from potentially days down to just a few hours.
Speed of information equals speed of rescue.
Exactly.
And the sources also mentioned a different kind of barrier in these global crises. Communication.
Oh, that's a massive logistical and human challenge. You have international teams work with local populations, all speaking different languages.
So how does AI help there?
AI translation tools, especially the newer ones using neural networks like Google's system, have become vital for aid organizations. They can instantly break down language barriers during triage or logistics coordination or just talking directly to survivors. It removes that delay of having to find a specialized human translator, which can take hours or even days.
Let's pivot now to a sector that really shapes our future: education. Historically, education has had this massive problem with scale, right? How do you give a personalized lesson when you have 30 kids in a room?
It's the classic one-size-fits-all model, and it fails the student who's struggling, and at the same time, it fails the student who's ready to move faster. AI platforms are now tailoring the learning experience to the individual student.
The case study from the Texas school district, they use this for math remediation.
Yes, and math remediation is a notoriously difficult area to manage at scale.
So what was the system actually doing? And what were the results for those struggling students?
The system was constantly assessing each student's mastery level with little quizzes and exercises. But instead of just giving a grade, the AI analyzed why they got a problem wrong.
So it's diagnostic.
Highly diagnostic.
Yeah.
Was it a fundamental misunderstanding of fractions
Mm.
or a problem with basic algebra? Based on that analysis, the AI recommended a completely personalized lesson path for that one student.
And the outcome?
It was transformative. The struggling students improved their math scores by 34% in a single semester.
34%.
A huge leap. But the crucial point is that the AI didn't replace the teacher. It augmented them. It gave the teachers real-time analytics, not just grades, but deep insights into the conceptual roadblocks for every single student.
So it allowed them to shift their energy.
Exactly. It let them focus their time where human intervention was most needed. They could go from being general lecturers to being these data-informed, highly targeted mentors.
That's a profound point. The highest use of AI in so many fields isn't replacement, it's elevation. Elevating the quality and the focus of human effort.
Absolutely. The machine handles the repetitive assessment and customization. The human handles the motivation, the empathy, the complex discussion.
Okay, finally, in our industry overview, public safety and smart cities. This is a tricky area. The power to predict has to be balanced with, total transparency and ethics.
It does. And when it's deployed with strong governance and clear standards, AI can be a massive help for public safety. The example cited was a major U.S. police department using AI heat mapping.
Which is a form of predictive analytics.
Right. And the system didn't just look at past crime stats. It combined that historical data with dynamic, real-time data time of day, weather, local events, even social media chatter, to proactively identify these tiny micro areas that were statistically likely to become crime hotspots in the next 48 to 72 hours.
And did this proactive approach actually reduce crime?
The metrics were pretty clear. The city saw a 12% reduction in violent crime in 1 year in the areas where this system was deployed.
And how did it achieve that?
Not through more surveillance, but through smarter resource allocation. It helped the department deploy officers more effectively to high-risk areas during peak windows. This acted as a deterrent and also just allowed for faster response times citywide when an incident did occur. It was using intelligence to put officers where the data predicted they'd be needed most.
That deep dive into specific industries really lays a powerful foundation. But AI's ability to optimize systems goes way beyond just one company or one sector. It can address these huge, persistent global challenges.
That's right. The same ability to optimize a complex logistics system for a corporation can be applied to global betterment, especially around issues of equity and access.
The sources specifically mention poverty reduction. How does AI help make sure that limited government resources actually reach the people who need them?
It's all about optimizing distribution. AI can analyze vast demographic data, need assessments, and logistical bottlenecks to make sure essential resources like food aid, healthcare vouchers, financial assistance are distributed efficiently.
These programs often suffer from huge administrative waste.
Exactly. And misallocation. By using AI to target and verify need in real time, it ensures the aid gets to the most vulnerable people, cutting down on that waste and dramatically increasing the impact of every dollar spent.
So it's a shift from just generalized aid to hyper-targeted, verified delivery.
Precisely. And another critical area is accessibility and inclusion. This is truly life-changing for individuals with disabilities.
What are some examples of that?
Well, tools like sophisticated real-time speech-to-text or the AI-powered captioning we see now, or predictive smart assistants. They are breaking down barriers that used to prevent access to education and employment.
Can you give us a specific scenario?
Sure. Imagine a visually impaired student getting an instantaneous, highly accurate audio description of a complex technical graph in a textbook. Or a deaf individual participating fully in a fast-paced corporate meeting because the live captioning is flawless. These are just conveniences. They level the playing field. They ensure people with disabilities have full access to communication and careers, which accelerates their economic participation.
And looking at the bigger economic picture, how does AI accelerate development for, say, small businesses?
Through that same optimization, AI-powered logistics makes supply chains leaner, reducing waste and shipping delays, which is a major cost for any business. And for small businesses and entrepreneurs, AI gives them immediate access to sophisticated market analysis tools that used to be only affordable for massive corporations.
So it lowers the barrier to entry?
It lowers the barrier to entry, it increases the productivity of small teams, and it gives them the analytical firepower to actually compete in global markets.
Okay, it's clear the power here is just immense. It touches every part of our lives. But given that scope and the autonomy we're giving these systems, we have to talk about the ethics, the stewardship.
This is the essential conversation.
Because if we don't build in robust guardrails, the potential for harm is just as great as a potential for good.
It is. This power demands a really strong framework of ethical considerations to ensure these systems are fair, transparent, and this is critical accountable when they make mistakes. Without that intentional stewardship, public trust just evaporates and the solutions won't last.
Our sources laid out 4 essential pillars for ethical AI. Let's walk through each of them, starting with bias reduction. This is the one we probably hear about the most.
And for good reason. Bias reduction is paramount. Because if you train an AI system on a data set that reflects historical societal prejudices.
Like old lending data that was biased against certain groups.
Exactly. The AI will just learn that prejudice and then automate it at a massive scale. It won't fix the systemic problem. It will just make the discrimination faster and more efficient.
So how do you combat that?
Developers have to rigorously audit and balance their data sets. It's not just about accuracy anymore. It's about ensuring the data reflects equitable outcomes. And if the historical data is biased, you have to intentionally introduce balancing techniques to prevent the AI from just reinforcing past injustices.
The next principle is explainability or transparency. This feels absolutely necessary for trust, especially in high-stakes decisions.
It is. We can't have black boxes making life-altering choices. Explainability is the requirement that an AI's decision-making process must be understandable to a human.
So if an AI denies a mortgage application,
The person affected, or a human auditor, needs to be able to know why. What factors led to that decision? Without explainability, you can't audit the system for errors or for subtle biases.
it becomes an uncontrollable agent.
Exactly. And users lose confidence instantly. It's antithetical to ethical deployment. The development process itself has to focus on making the logic, even of a complex neural network, interpretable to a human expert.
And what about data privacy? I mean, these models are so data hungry. How do organizations protect sensitive information while still feeding the AI?
This is non-negotiable. As these systems ingest more and more data, organizations have to adopt advanced privacy-enhancing technologies, things like data anonymization, or increasingly, a technique called federated learning.
What's federated learning?
It's where the AI model actually learns from local data without the raw data ever leaving the person's device or the organization's server. The insights come to the model, the data stays put.
That's a big deal.
It's a huge deal for trust. A single large-scale data breach from an AI's training data could be catastrophic. It would destroy public confidence.
And finally, accountability. This feels like the hardest one. If an autonomous system like a self-driving car causes harm, who's responsible?
This requires clear legal and operational frameworks to be established before the system is deployed, because the lines of responsibility can get dangerously blurry. Is it the model? The data? The developer? The company that deployed it?
So you have to define ownership up front.
You have to. Who is accountable when the system makes an error? You have to establish that clarity to ensure there are mechanisms for recourse, for compensation, and for correction. It reinforces the idea that humans are, and must remain, ultimately responsible for the intelligent systems we create.
That transition from broad societal impact and the necessary ethics really sets the stage for our final section. How do you translate all this into focused, real-world business solutions? We're going to use Winning Team AI as a model for this intentional approach.
Right, so we're shifting from the big theoretical potential to the practical implementation. How do you deliberately engineer an AI to solve a specific complex business problem and do it quickly? The philosophy here is all about targeted automation.
Okay, let's look at their core offerings. They seem very focused on creating these highly specialized automated agents and AI assistants. What's the difference between, say, a general chatbot and one of these agents?
It's a huge difference. A general chatbot might answer some FAQs. These specialized agents are designed to execute complex, multi-step business processes that used to require a senior human employee.
Like what?
For general operations, they build AI assistants that can gather detailed project requirements, autonomously generate a complex project plan, or even draft comprehensive standard operating procedures, the SOPs.
The step-by-step instructions for tasks.
Right. And that automates huge blocks of daily repetitive work. It lets the human employees shift from doing the work to overseeing the work.
And the industry-specific agents you mentioned, that implies a massive amount of domain knowledge is somehow embedded in the AI itself.
It is, and these agents function less like an assistant and more like an expert consultant. They're designed for highly specialized tasks.
Such as?
Agents for planning an Oracle cloud migration, for doing pre-evaluations of legal cases, for managing financial debt relief platforms, or for handling compliance and AI governance.
And you said the key difference is that they ask questions.
That's the key. They don't just wait for an input. They ask expert-level discovery questions based on the domain knowledge they were trained on. So a cloud migration agent will start by asking about your current infrastructure, your security needs, budget constraints, compliance mandates, all in a highly structured, strategic way. It ensures no critical step is missed.
The idea that an agent can ask expert-level discovery questions, that's a game changer. It's acting like a consultant, accelerating that critical initial planning phase.
It is. It uses its training to guide the whole process and ensure the output is strategic, accurate, and immediately actionable. It eliminates all those hours humans used to spend just figuring out what questions to ask in the first place.
And what about the impact on smaller companies? The sources detailed how AI can let a small team function like a full department.
Yeah, the automated content and marketing systems are a huge productivity multiplier. Small or medium-sized businesses can use these tools to automate their entire marketing lifecycle.
From start to finish.
Pretty much. Generating sophisticated ad copy, creating high-quality blog content, building and managing complex sales funnels, launching integrated email and social media campaigns. This lets a tiny team, maybe 3 or 4 people, perform with the output of what used to be a full 12-person marketing department. It just demolishes the cost barriers and gives them a huge competitive advantage.
Okay, now let's get to the part that really grounds this whole deep dive, the real-world business metrics. Let's quantify the time and money savings with those 2 examples from the source material. Start with the construction firm and their AI project migration agent.
Right, so this construction firm was facing this really critical, really complex Oracle cloud migration. These projects are notorious for being time-consuming and risky, especially in the planning phase.
And they use the migration planner agent.
They did, and this is where the time savings become almost hard to believe.
Okay.
The total planning time for this complex, critical project was reduced from 40 hours of manual work by their senior technical staff down to just 3 hours.
40 hours down to 3, that's a 92% reduction. That's staggering. But I have to ask a skeptical question here.
Please.
What happens to the institutional knowledge that gets built during those 40 hours of human planning and discussion? Are you just accelerating the process but losing the crucial learning component?
That is an excellent question, and it speaks to that intentional design we've been talking about. The goal isn't just speed, it's augmented output quality. So in this case, the human team still reviewed, they ratified, and they refined the plan. But their job shifted. They went from creating the framework from scratch to validating and customizing the AI-generated one.
So the AI did the heavy lifting.
Exactly.
Right.
In those 3 hours, the agent generated a full, comprehensive project plan, the architecture diagrams, a detailed timeline. And critically, it automatically identified potential technical and financial risks and even areas for cost savings. It delivered an output that was 95% ready to go. The institutional knowledge was captured in the final document, but the human brainpower was focused on strategic risk mitigation, not administrative drafting.
That makes the acceleration sustainable. It moves the human effort up the value chain.
Okay, let's look at the customer-facing side. The retail business that integrated an AI sales and customer support agent. What were the metrics there?
So this illustrates the ultimate goal of enterprise AI, optimizing both sides of the balance sheet.
Cost reduction and revenue growth.
Right. On the cost reduction side, the system handled all the common inquiries 2,047. This led to a 70% reduction in customer support tickets that needed a human to intervene. That's just massive operational savings right there.
70%. And how did that same support agent also become a sales engine?
So the agent wasn't just solving problems, it was analyzing customer data and their interaction history in real time.
For example,
If a customer was asking about the warranty on a product, the agent would instantly recommend complementary accessories or upgrades based on predictive modeling of what similar customers bought.
it's upselling intelligently.
It's proactive, personalized engagement, and that led to an 18% increase in monthly sales. Wow, so it turned a cost center customer support into a revenue generating asset.
Through smart, timely personalization. That's the ultimate demonstration of intentional design. An AI that is both a cost-cutting efficiency tool and an engine for revenue growth. It is. And it brings us right back to the central idea that unites all of these examples, from the hospital saving lives to the retail agent boosting sales. AI becomes this unstoppable force when it's built with clear intention, when it's focused on solving specific, meaningful, everyday problems, and when it's aligned with those transparent, ethical standards we talked about. So to summarize the impact for you, the learner, the scope of AI's practical application is already enhancing medical diagnostics with 20% greater accuracy. It's improving disaster response by guiding rescue teams 10 times faster, and is allowing businesses to operate with unprecedented efficiency, like cutting critical planning time by over 90%. The real power of this moment isn't in some far-off theory of general intelligence. It's in the purposeful application of focused AI to achieve measurable human and business outcomes today.
This knowledge then requires you to look inward now. We've seen sophisticated AI systems reduce customer support tickets by 70% and cut critical migration planning time by over 90%. So consider the systems and processes within your professional world. What complex, time-consuming human processes in your field, the ones that eat up days or weeks of manual, repetitive, yet essential effort, are now ripe for immediate ethical automation? That is the profound, actionable question worth exploring on your own.